I'm Stephen Foskett, and this is Cloud Field Day in San Jose, California. We're here with Cisco Systems and a panel of bloggers, podcasters, writers, and speakers. We invited them here to interact and discuss during the presentation and also to represent the wider IT audience. If you'd like to see more videos like this, you can look at youtube.com/techfieldday, or you can go to techfieldday.com and learn how to become a presenter or a delegate yourself.
Hi, everyone. My name is Gaurav Manglik. I'm Senior Director of Engineering for the CloudCenter product. CloudCenter was formerly CliQr, a company that Cisco acquired earlier this year. I was one of the co-founders at CloudCenter. So I think what I want to talk today about is CloudCenter, give you a technical overview of the product, get into a little bit more technical details as well around how the product works, what it does, and then we'd love to absolutely show you a demo at the end of this presentation. So what is CloudCenter? At a very high level, CloudCenter is what analysts would call a hybrid cloud management platform. Really what it allows is enterprises to easily create application models. We call them profiles. Those models are used by CloudCenter to automate the deployment and management of those workloads on underlying infrastructure environments. Those infrastructure environments can be on-premise, virtualized data centers, for example, vCenter, OpenStack, CloudStack, Azure Pack, etc., or can be a variety of public clouds that we support out of the box, such as Amazon, Azure, Google, Rackspace, IBM, etc. So maybe it would be useful to touch upon the motivations behind CliQr, now Cisco CloudCenter, before I proceed into a little bit more technical details about the product itself. I think motivation one, when the product was founded, was basically data centers were getting very complex. Data centers were at the same time becoming software-defined. Because of the software-defined nature of those data centers, one could write automation scripts to programmatically control the compute, storage, and networking on those data center environments. If it's an on-premise data center, you talk into on-premise APIs, but if it's a cloud like Amazon, then you talk to Amazon APIs. So while that was great, however, all the automation was still happening at the infrastructure level. Application automation came on top of the infrastructure automation. Infrastructure was driving applications, not the other way around. So our motivation one with CloudCenter was everything should start with application models. The application should drive the infrastructure setup and configuration. The infrastructure shouldn't be required to be set up first. Once you start with the application, the complexity of the data center goes away. End users, our end users who are typically app devs, application developers, or application administrators, don't need to worry about the infrastructure complexity itself. That was motivation one, and drive automation, drive efficiencies based on those models. Motivation number two, this was beginning to be true about 5 years ago when we founded the company, definitely very true right now, was that when we talked to the enterprise, every enterprise was looking either today or in the future at a hybrid environment. Nobody was on a single infrastructure type. Data centers were becoming heterogeneous. A typical enterprise that we talk to today has on-premise vCenter, VMware for virtualization. Some of them have OpenStack going towards production, some in a lab environment. And there might be also several teams running a different set of workloads on cloud providers like Amazon and Azure. So the other motivation was, if we can drive automation, if we can drive management from an app perspective, can that management, can that automation work across multiple clouds without lock-in to any one infrastructure? And so that's what CloudCenter does today. CloudCenter provides a single platform. It's all software. I'll go into the architecture. It's a distributed software architecture. That architecture runs on top of different cloud environments. So let's say you're a large financial services company running out of New York, and you have on-premise VMware, but for some workloads, you're also beginning to use Amazon and Azure. Those cloud environments will be set up beneath CloudCenter. Your users will be coming to CloudCenter, creating their application profiles or application models, and deploying them across those environments. So let's dive into a little bit more detail. And this was an example that was used by one of our early customers, a very large name in the media and entertainment space. They were looking at multiple environments for different applications and different groups. So they did an evaluation. They looked at a custom web application. Typical web applications that they're running on their cloud environments tend to be three-tier, multi-tier applications for databases, app servers, load balancers. In order to automate the deployment of such an application on, say, an Amazon Web Services, you would have to write a set of scripts. Typically, the scripts are written by different people. There would be an infrastructure script that calls into Amazon APIs like EC2 to get the right VM instances, attach the right block storage, EBS. If your application tiers have certain firewall requirements, network security requirements, then you have to place those different tiers on different VPCs in Amazon. Between those different tiers, set up the right network ACLs. On Amazon, that's done through security groups. All of that work, in order to automate, there has to be some kind of a script, some kind of a workflow that's required to be written. In a traditional enterprise, I mean, things are changing now in a modern enterprise where an app dev can do the entire scripting, but in a traditional enterprise, it's not even one person's task. It's typically an infrastructure team that's tasked with managing the infrastructure, and a separate team that comes in and does the application scripting on top of that. That's just the infrastructure automation. From the application standpoint, on all the VMs that come up on the cloud environment, you have to install your application services, your databases, your middleware, your load balancers, load up your application artifacts, configure the different application components to be able to talk to each other, and that they also need to start in the right order. That's a fairly complicated script or workflow to write. I think this particular customer, they were looking at 1,500 lines of code in script for something as simple as a 3-tier web application. The other thing that they saw was a lot of their development work was being sanctified, if you will, on a cloud like Amazon. But in production, they wanted to run those workloads on their on-premise VMware environment. So if you do invest all that time, in creating a script on Amazon, that script does not translate to your VMware environment. That script has to change. In their evaluation, about 20% of the script needed to be changed to change the APIs, the Amazon API calls into VMware vCenter calls. So that was the fundamental problem that we were trying to solve with CloudCenter, that instead of taking a infrastructure up script-based approach, how can we take a top-down application-based approach? So let me jump straight into a UI screenshot of the product. And this is what we call a topology modeler or topology designer inside CloudCenter. What this allows the end user to do is to create that 3-tier application workflow, model it as a blueprint instead of having to write any cloud-specific scripts. So I'll get into a little bit more detail around this topology builder, but on the left-hand side, what you see here is a library of building blocks. We call them services. These building blocks can be components that come up inside a virtual machine or a target cloud environment. They can be containers like Docker, or they can be even PaaS services. These can be on-prem PaaS services, like an Apprenda, like a Cloud Foundry, or can be cloud-specific PaaS services like Amazon RDS or DynamoDB or so forth and so on. So what the end user has to do here is drag and drop the elements that make up their application. So here you see a load balancer, there's an app server, which is Apache, there's a MySQL database. Connect the different tiers. The connections, the arrows that you see here are basically the interdependencies between the different tiers. What this tells CliQr CloudCenter is that the load balancer is dependent on the web server to be successfully started before the load balancer can be brought up, and the web server is dependent on the MySQL. So it's truly a service dependency. And in this modeling exercise, the user, and we assume the user is an expert on their app, but not necessarily on the infrastructure, that user can provide further application-specific properties and requirements. So as an example, for the web server tier, the user can provide the web server-specific properties. Here's my zip file sitting in this repository that needs to be loaded up inside this app server. My app server also needs to run as a cluster. The min nodes in a cluster are 4, the max nodes are 100, so forth and so on. Also, this app server has certain requirements from compute, storage, and networking. For compute, it needs X number of CPUs, so much memory. It needs a certain kind of storage. Yes?
Do you have are you going to do a demo of this at some point?
I'm going to do a demo.
Do you think, I know some people actually get a better understanding to see the demo first, and some people on Twitter are saying, yeah, I can't wait to see the demo. So I don't know if we want to do the demo and then.
So let me quickly fly past this and let's do a demo. So I'll get to the architecture first and then do the demo.
Okay. Thanks.
Great idea, absolutely. So that's the idea. You create models. The models capture the infrastructure requirement. In the demo, I'll show you some more details on how the models can be customized. I showed you a 3-tier model. A lot of our customers don't actually start out with the 3-tier blueprints. The model that they start out with is just a single VM with a base operating system image, and they're running a Puppet module or a chef recipe on it. Or this is, by the way, a fictional application. There are customers with real applications that look pretty complicated, but the model can be a composite model as well. It can be a mix of PaaS services, containers, and VMs. Today, we don't see a lot of users going whole hog with PaaS services or whole hog with containers. very often their topologies are mixed. So your database might be on a VM, your app server might be a container, and your load balancer might be an on-premise F5 modeled as a PaaS service. So this modeling actually allows you to create such composite blueprints. Once these blueprints are created, you have basically these models. Behind the scenes, these are all JSON metadata, basically. These are available to the user. The user can share these models with other users with different permissions. Maybe you're a dev user, you want to share this with your QA counterpart, but without any edit permissions. All of that profile management can be done here. A very common use case that we also see is these models are actually pushed into another catalog, a front-end marketplace, if you will. That shopping cart can be inside CliQr. We have basic shopping cart functionality. Sometimes it can be a different ITSM front end, like Cisco has an offering called Prime Service Catalog, and we also have an integration with ServiceNow.
What kind of integration? So integration ServiceNow as a service catalog integration?
It's a scoped application within ServiceNow.
Okay.
So this is a ServiceNow scoped application. The user goes through a ServiceNow workflow where they can order service catalog items inside ServiceNow.
Okay.
Those catalog items are basically these blueprints.
Okay.
In ServiceNow, you go through an order approval workflow.
Yep.
Once the approval is obtained, then that calls into CloudCenter through REST API. Through everything that we have in the UI has an outbound REST API.
Any communication back to ServiceNow?
Yes.
Okay.
So once the application gets deployed, then we update the CMDB inside ServiceNow with also metering information. So you can then use ServiceNow as your front-end chargeback or showback and integrate with billing as well.
Okay.
You said that was SOAP or REST? What's the
REST APIs.
Okay.
Yeah. We also have a northbound message bus interface. So there's UI, there's REST API, and there's an event message bus as well.
Okay.
So those are models. Again, we'll dive into more details in the demo. Once the application is deployed, actually, let me step back here. So when the user deploys the application, and I just want to briefly touch upon this now, that's where the user gets to select the target infrastructure where you can deploy the application. So the user can select VMware or Amazon or Azure. It's the administrator's choice, and this administrative aspect of the product is really, really important for enterprise IT when they're looking to buy a product like CloudCenter. The administrator can set up governance policies where the cloud choice could be bubbled up to the end user, or the cloud choice is defaulted. The cloud choice could also be based on some kind of policy, a governance policy. So you could have a governance policy that says this user is in Germany, and so this user has an access to a tag called Germany, but no other tags. So when the application gets deployed, they will pick a Germany tag, which will limit them to German data centers for compliance and governance reasons. Or here's my dev user. The dev user associates a dev tag that automatically goes to Amazon on a particular Amazon environment with particular instance types, and they can go nowhere else. And on that environment, there are certain policies that are enforced automatically, like, say, auto-aging. But if it's a different tag, that drives the data center or the cloud selection differently. So, we hear this in the industry a lot, bimodal IT, but that's sort of the goal here, where end users get the simplicity, the flexibility, and the self-service nature of building out applications, but IT can still govern what they're doing. A lot of day 2 and day 3 functionality, which I will not demo today, but essentially once an application is deployed on the cloud, day 2 functionality includes things like ongoing management of those deployments. We meter the deployment. You can shut them down, you can restart them, you can do patch, you can upgrade them. DevOps is a very common scenario, so there's a functionality called promote, where you might have deployed an application to a dev environment, but then you can promote it from dev to the next stage. And the stages that you have defined, it's flexible, it's customizable.
And do you have like authorization workflows? Is that stuff built in?
Between dev to QA to stage to prod, we do have an authorization workflow. So basically, the QA admin would have to approve the deployment, or you could automate it as well. For more complicated pipelines or workflows, it would be better to use a DevOps tool in front of CliQr, and then have that tool call into CliQr for the actual deployment. So it could be IBM Urban Code, it could be Zebia Labs, it could be very common use case for us is just Jenkins. We have actually an out-of-box Jenkins plugin. So when a dev user comes in and they kick off a build in Jenkins, your build artifacts will get uploaded to some repository, say Artifactory, but that Jenkins will also update our JSON metadata directly, import it into the system, revision the profile, and then kick off an automated deployment. when that automated deployment kicks off, the developer there is not specifying the target cloud. That target cloud gets driven off the tag. When the development completes, the user will get an email notification. That email notification can be used to trigger off an automated test case. On the success of that test case, you can promote it to the next stage.
Okay.
So the next stage, when it gets promoted, the QA admin would get an email, and they can directly approve that from the email. Yeah.
Are you guys planning on building anything into that for release pipelines? Something like a code stream or something similar into the product, or?
We have something already. We have actually a project view. Okay. So you can define project views. It looks like Trello. I'll quickly show you in my demo as well. So you can create your multiple stages, and in those stages you can assign different stages to different users. Different stages can also be assigned to different clouds, and then you can have a budget by stage or by the entire project.
Can you create like gating rules? So if I have a test to go run and then it has to meet, pass or fail to move on to the next stage.
We don't have that today. We don't have that today.
But is there a plan to? And if you can't talk about it, it's okay. But
yeah,
are you going to build that or just rely on the ecosystem?
I think for something like that, we are still awaiting on customer feedback on what's the best way they want to use the tool. Do they want that functionality to be in their existing tool outside of CloudCenter, or would they really want everything to go inside CloudCenter?
Okay.
So we are also trying to limit the scope of what we are doing. We can be one and everything for everything.
So that was my next question, right? Is this being positioned as a competitor to VRA, to RightScale? Is it more?
It's a competitor to VRA and RightScale.
Okay.
So I think the key difference is, we started off, we actually used to admire RightScale a lot. I used to work at VMware before I started the company. And used to admire RightScale a lot. In fact, I thought I would go work for them at some point of time. RightScale really started at a point when Amazon had no management of its own. And the only way to manage Amazon was RightScale. And RightScale did a terrific job at it. But everything was done based on chef templates. And that's the old way of doing things, where you're really creating those chef scripts. And what happened along the way is the enterprise went hybrid. And as soon as that started, it became a little bit difficult for RightScale to manage multiple environments. Every chef template had to be customized for every cloud, and so they couldn't keep scaling up. So for us, that I would say is the key difference between RightScale and CliQr. RightScale is more of a chef template, script-based approach. This is a model-based approach. And I'll go into the IP a little bit on how the model actually drives the infrastructure as well.
Yeah, I'd like to see that.
The other key differences from RightScale is been typically a SaaS offering. They can do on-site installs. For us, it's the other way around. We are typically an on-site install. Yeah. We can also offer SaaS.
Would you position this as the service catalog for an organization? I mean, we see VMware pitch VRA as the front end for not just IT, but other things. I'm a believer in ServiceNow. Is that?
We don't pitch this as the front end catalog because that's overshooting what we can do.
Okay.
We typically see customers already using ServiceNow as the front end catalog. And so that's why we prefer the integration path. There's Prime Service Catalog, that's a front-end catalog at Cisco. Okay. So PSC has an integration built into us as well. A front-end catalog can also come with extra functionality beyond what we do. Like you can have a shopping cart-like experience.
Yeah.
And that's again, we would prefer that a front-end to us would take on that functionality.
I agree with that. Good.
Yeah. Is this going to replace Intercloud Fabric, or is there still development going on in that space?
I think the overall vision is that the visions that Intercloud started out with is met by CliQr. Yeah. So overall, what will happen over time is there is still good IP in Intercloud Fabric that we will be taking inside this product and providing a very cohesive, comprehensive picture to customers.
Okay.
There are things that Intercloud Fabric did and does that we don't do. One of the things that they do is data replication. We don't touch the data. We rely that the customer has set up the data replication or is moving the data or has put it in a repository. With Intercloud, we will be able to do that.
All right. Okay.
Intercloud also had an image transformation capability. So if you have a base image on your private cloud and you want to replicate that base image, turn it into an AMI, Intercloud has that capability as well.
Okay.
So there are some things like that we will be lifting from Intercloud.
Okay. Well, I asked because that relies on Prime Services Catalog, so I didn't know if that was sort of going to go away.
Intercloud does not, actually. Intercloud was relying a little bit on UCS Director.
Well, in the back end, right, if you want to provision something out to somewhere, it was using Prime Services Catalog.
It was, I believe so. I'm not an expert on that, but there was some underlying tools, UCSD, SDP, that they were using.
Yeah.
Yeah.
Okay.
Yeah. Great. So for the demo, I'll spend 5 to 10 minutes on the architecture and then dive into a demo. So actually, this is the high-level architecture. The product is distributed. It's got two key components to it. There are two parts to it. Basically, there's a manager, and there's the orchestrator. So the UI that you're seeing is basically the manager UI. And this is a single virtual appliance. To some customers who want to actually install the software on their own hard-earned images, we also provide the software installation packages directly. This can be installed as a single VM, or you can actually run it in HA or DR as well. So it supports complete high availability. The manager can be accessed through a browser-based UI, or as I mentioned, there's an outbound REST API as well. So that's where the end user accesses CloudCenter. That's where they create those application models, those application profiles. The other key component of this is the orchestrator. So we chose that this architecture be distributed, not monolithic. The orchestrator is basically a virtual machine instance. Actually, it's two VMs, one for the orchestrator, and there's also a RabbitMQ per every infrastructure environment under management. So let's say a typical customer has two vCenter data centers, and they're also managing one public cloud, say Azure. They would install one orchestrator on each of those clouds. So the orchestrator is what's doing the heavy lifting on that environment, which relieves the manager of a lot of the workflow orchestration stuff. The orchestrator takes care of that. So when you create that application blueprint in the manager, when the user decides to send it to vCenter, that profile goes to the vCenter orchestrator. The vCenter orchestrator strips open the profile to automate the infrastructure automation tasks and the application deployment tasks on vCenter. So on vCenter, it will call into vCenter specific compute and storage APIs. If there is no SDN layer set up, we'll directly talk to vCenter networking. If there is NSX, we'll talk to NSX. If there is ACI, we will talk to ACI.
So what happens if you try to do something that cannot be implemented by policy? Like microsegmentation, NSX, I can't do that somewhere else. Do you warn me about that when I deploy, or does it just not happen?
So it depends, right? So if it's something like, let's take a very simple example. If your requirement was that I need 4 CPU VMs and those are not available on the target cloud, we just say that cloud is not available, right? In certain cases, and we need to do a better job in our product on reporting this in the UI, but in some cases, let's say the user in the profile has created a set of network rules, firewall rules between the different tiers. We just follow the underlying cloud infrastructure's network APIs to provision those rules. What's the guarantee that that provider is providing? We don't really know. We just work with that. So if it's something like ACI, it would be very comprehensive. There would be micro-segmentation rule set. We'll create endpoint groups. We'll create the right filters and contracts between those endpoint groups, and that's very comprehensive. But if the same rules are applied to Amazon, that just simply translates to Amazon security groups.
Okay.
Right. So obviously this is useful from a scale perspective because the orchestrator does the workflow automation, but also it does the ongoing management of the workload. So let's say you have set up an auto scaling policy for that web app. The orchestrator is implementing that auto scaling. I want to point out one more thing. So we do very basic systems monitoring like CPU utilization and so on and so on. But again, our goal is orchestration. It's not so much monitoring, compliance, and change management. That would be done by a solution outside CliQr. We can take events from such a tool and based on those events, take remedial actions inside CliQr. Great, so I think that's mostly what I wanted to cover on this slide. Oh, one key aspect as well, this is a multi-tenant architecture, so you are not installing multiple instances of the manager or orchestrator for every tenant. Let's say you're a service provider, and as a service provider, you want to service multiple customers, or even within the context of a large enterprise, you have multiple business units. You would only have one manager and an orchestrator, but all those tenants will be set up as different tenant accounts inside the manager. And our tenancy goes n-level deep, so tenants can have subtenants, subtenants can have sub-subtenants. Each tenant gets its own independent user management. Each tenant can also integrate with AD or LDAP through SAML 2.0 provider. So let's look at the orchestrator a little bit more in detail around how we have implemented the orchestrator. So the orchestrator has basically an interface layer around compute, storage, network security, images, and also pricing. I've only shown 3 here. And this is an abstract definition. This definition is about how to call those constructs on the underlying provider. That definition allows us to also bubble up cloud-specific infrastructure types, infrastructure settings. On every cloud that we support today out of the box, we have basically implemented this interface, the compute, storage, networking interface, specific to that cloud provider. So if it's OpenStack as an example, it talks to Nova, Cinder, Neutron. If it's Amazon, it talks to Amazon-specific APIs. If it's a different cloud provider, it talks to that cloud provider's APIs, basically. So the orchestrator, the workflow engine, is talking to the abstract APIs here. The abstract APIs get translated at deployment time to the cloud-specific APIs, and that's why that model that we have becomes cloud agnostic. Now, one might feel that because it's cloud agnostic, we are losing functionality from a particular cloud provider. And the way we handle that is the cloud-specific settings are typically the unique infrastructure functionality that cloud providers are providing. That is still bubbled up through cloud-specific settings up to the end user. So you can choose different Amazon-specific instance types, availability zones,
Or are you
VPC
doing that dynamically through the API? Or?
Where APIs are available, we pull in the latest. Where they're not, we have a metadata file that needs to be updated.
Okay.
Yeah. And where it's a private cloud, you can also create sort of your cloud-like definitions. On vCenter, you can have a small, medium, large instance, and those would be the instance types seen by the end user.
From the orchestrator perspective, what's the parity between yours and like VRO? So vRealize Orchestrator. So I mean, vRealize Orchestrator handles some of the heavy lifting, but I can go in and create my own workflows to do things that VRA won't do, and expose those back up to the catalog, and make that as part of an application blueprint or something like that.
Yeah.
Let me show you, and maybe you can help me answer the question as well on the demo. I'll try to show you what all can be done.
Okay.
I believe what we do is very, very comprehensive.
Okay.
I can be biased.
No.
Okay.
So the cloud-specific functionality that might not necessarily be generally available to other cloud environments, how do you manage that in that environment where you're talking to an orchestrator, which is effectively an API that crosses all clouds, and then you've got a cloud-specific layer that talks to specific to those cloud environments?
That's a great question. So, typically what's happening on the infrastructure side, infrastructure is getting commoditized, and the APIs that are pretty, can be abstracted. That's why this approach works. However, every cloud will have unique features, and that's how the cloud guys are actually differentiating themselves. Amazon is coming out with newer and newer PaaS services. Azure will have a different set of PaaS services. So those services are not abstracted out in that layer. Those services can be defined here in the building blocks. So let's say you do want to use Amazon DynamoDB. You can add DynamoDB to this building block layer. That DynamoDB can be part of your application blueprint. But in that case, the user is making a conscious decision that that part of the application is cloud-specific. It cannot move. Now, I predict, and I think this is something that is in our vision and roadmap, is some of these PaaS services will also can be abstracted. There would be equivalent PaaS services available on certain clouds. So everything is moving up the stack. The commoditization is also moving up the stack. And one of the things that we want to be able to do in the future is when you drag a load balancer here, it doesn't have to be an Nginx, HA proxy, F5, or Amazon ELB. You can drag and drop a generic load balancer. If the user decides to deploy it on Amazon, it should be ELB, but if on-premise, it could be an F5. So I think we would provide in the future functionality to be able to abstract out services, but the user would have to add the service abstraction. One last architecture slide, and I'll run straight into a demo. The other useful aspect about this whole model is because it's app down, end users are working with app profiles, and they're deploying these app profiles to what we call a deployment environment. A deployment environment is a logical construct inside CloudCenter. An administrator would be setting up what a deployment environment means. So an administrator might say a deployment environment is called dev, and it maps to Amazon, while a different deployment environment called prod maps to vCenter. And then the placement logic between application profile and deployment environment can be tag driven, And if a deployment environment is mapped to multiple infrastructure types, the selection of the infrastructure could be a choice that's manually bubbled up, could be defaulted with still flexibility, or could be locked down. And that's the marketing slide. Great, any questions so far?